right, today we have one more congruence postulate to learn. We learned 4 in our previous lesson, and there's one more. But the reason we gave it its own day is because why? This one only works for a certain breed of triangles. It only works for right triangles. What's another theorem that only works for right triangles? Pythagorean theorem, yes. So this one and Pythagorean are unique. They're specific to right triangles. Let's do a little bit of reminders about what we call the sides of a right triangle. So we have a right triangle that always has a right angle. That's a characteristic of a right triangle. The hypotenuse has to be located. If you drew an arrow away from the box, that's where the hypotenuse is located. And then the other two sides, kind of like in an isosceles triangle, the other two sides are called legs. Okay, so we need to know that vocabulary for today's postulate or theorem. This is number 5. Put this in your notes. This is the abbreviation, HL. This is the name, hypotenuse leg. And then there's a picture for you, and I'll talk more about it once you write it down. So if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then you're done. The triangles are congruent. So we have all these side, 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 angle, 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 side, and then this random hypotenuse leg, HL. So notice what we have in our picture. We have right angles. We have tick marks on the hypotenuse. And we have tick marks on the leg. So those are all necessary elements that we would need to prove them guilty of being congruent by hypotenuse leg. So there's 3 things you need to check each time if you want it to be hypotenuse leg. You can write this down if you want to, or kind of self-explanatory. You need a right angle. Don't try to accidentally use hypotenuse leg without 2 right angles. That's the first step. It has to be a right triangle. Then you need tick marks on the hypotenuse, and then you need tick marks on just one of the legs. Not both of the legs, because that would be side, side, side. So you need a right angle, tick marks on hypotenuse, tick mark on leg. Now, if we had been given this triangle on Friday, which I purposely did not give you on Friday, we would have looked at this, and we would have said not possible, because this would have been our side, angle, not between the sides. This would have been our side, angle one. You wrote that down as one of the ones that didn't work. So I'm just giving you a warning. That one does work, but it only works for right triangles. So it still does not work in all other triangles. But this one actually does work only in right triangles. And you don't call it side, angle on your quizzes and tests. You call it HL. And if you're wondering why this works only in right triangles and not in the other ones, it only works here because of Pythagorean theorem. Pythagorean theorem doesn't work in any other triangles, but since Pythagorean theorem works here, if we did c squared minus a squared, and we did it both times, we would get the same exact b both times, meaning side, side, side. You know what I mean? So that third side has no choice but to be congruent. Pythagorean theorem is why it's special to right triangles. Yay, Pythagoras! Okay, here's just a reminder of the ones that don't work on regular old, regular old triangles. And the rest of class is going to be practicing. You guys might not be using whiteboards, but we're going to practice lots of examples. So yeah, the first example I give you is not possible. Yes, sorry about that. But you do need to be careful, because it sure looks like hypotenuse leg. Yay! It's our new theorem. We're using our new theorem. Ooh, and then you go to the other one. You're like, uh-oh. This one's like side angle side. And although both of those theorems work, we're trying to prove these guilty of being congruent to each other. So they have to match each other. They need to have the same theorem for both ones. And so those don't have the same amount of data. And so the evidence says, not possible for us to prove them congruent because they don't match. Okay, so as we're looking at this example, I want to explain something that's very important for when we are deciding if they're congruent and what theorem we're going to list. I usually don't say this very often, but I do not want you to dig very deep here. I want you to stay on the surface, because if you kept going if you went further in the evidence that you're getting, you could prove them congruent by any of the 5. Well, maybe not hypotenuse leg. Here's what I'm saying. In this picture, the most obvious marking to add to your picture, the easiest, the one that makes the most sense is right here. Reflective property of equality. In fact, I want you to always look for that one first. When I have that evidence, I am done. Do not dig deeper. The answer is angle, angle, side. That side's not between the angles. So the answer is angle, angle, side. Here's how you could dig deeper, and this is what I don't want you to do, because this defeats the purpose of having shortcuts. Here's what you could have done. What kind of triangle is triangle ACD? Ooh, it's isosceles. And by the converse of the isosceles triangle theorem, if 2 angles are congruent, then the sides opposite are congruent. Another thing I know is that, wait a minute, if I have an isosceles triangle, and this is an angle bisector, in an isosceles triangle, when you're one of the special segments, you're all of them. So that is a median, and it's an angle bisector, and it's a perpendicular bisector. And it's an altitude. Do you see how I could dig so deep that I could end up putting all these markings on my picture and fill the whole picture up? That's the problem. These theorems, the reason we have these is so that we don't have to check all 12 things. So we're not doing unnecessary work. That's what the theorems are for, to avoid unnecessary work. Because in the real world, that's time. And time is money. You don't want to waste time in the real world. So don't go past the most obvious one. Okay? It's angle, angle, side. Don't do more work, or it defeats the purpose of us even learning these theorems. All right. Are the triangles congruent? If so, state the congruence theorem. Remember, the thing I want you to always add first, shared side, reflexive property of equality. Ooh, this is our new one. You see it? It's our new one. We know that there's a right angle there because 180 minus 90 is 90. And so these triangles are guilty of being congruent by hypotenuse leg. There's a hypotenuse. Tick marks on the hypotenuse. Tick marks on the leg. They're both right triangles, so we are hypotenuse legging that one. Is that a verb? All right, here's another one. Reflective property of equality. 2 right angles. Check. Tick marks on the hypotenuse. Check. Tick marks on the leg. Check. Hypotenuse leg. Does that mean that every right triangle is going to be hypotenuse leg? No. But if you do see right triangles, I would check for that one first. Okay, I wanted to make sure we got to these because these are the good ones. What additional information do you need to prove the pair of triangles congruent by HL? What additional information do you need? Here's what we don't put as an answer. Tick marks on geo. That's not the answer to this problem. Because we already have that. We're good. That's a reflexive property of equality. That's not additional information. Now, if I were just given this problem, I would say NP. I would say NP because it's missing something. It is missing this right here. Here's a few ways that you could answer this question correctly. You could write, what additional information do I need? I need the measure of angle M to equal 90. Or you could even get creative, and you could say, I need angle E to be congruent to angle M. Wouldn't that work? Because angle E is 90. If I force it to be congruent to M, it makes M 90. Or if you want to, you can say angle M is a right angle. But I really prefer the first two because I like how they're more precise. And we're not writing as many English words, just more math symbols. Okay? Try the next one, but don't type your answer in the chat yet, please. So, the directions say we have to make them congruent by HL, right? We have to make them congruent by HL. So, I have a leg, I have a right angle, and I have a leg. What I don't have are 2 congruent hypotenuses. Okay, so anyway, What I need is this to be congruent to this. I need those tick marks. That can't be your answer. I need tick marks. You can't say that. You have to say it in precise mathematical vocabulary, which would look like this when you write it on your homework. I need AC to be congruent to DF. I know it's hard to type that in the chat. All right, let's try some more. Are the triangles congruent? If so, state the theorem. Reflects the property of equality. What do we write? What's our answer? Very good. Not possible. This one spells a bad word. Side, side, angle. There's no redeeming qualities here. There's no right angle. So remember, that one never ever works unless it's a right triangle. Since this isn't a right triangle, doesn't work. You write not possible, move on. Are the triangles congruent? So do you see why those dotted lines are there? They're to show that this whole side needed a tick mark and this whole side needed a tick mark, but they couldn't put it on the sides because they were overlapping. So let's try this one. Be careful. So something happens in this example that's never happened before. We've had plenty of shared sides. We've never had a shared angle. So if you want to look at what two triangles we're looking at here, we have this is one of our triangles, the green one, and this is our other triangle, the blue one. They're actually sharing an angle, which has never happened. That's the reflexive property of equality, but we've only used it with sides before. They have this angle in common, just like the other ones had a common side, a shared side. This is a shared angle, believe it or not. Oh, I need to put double R's. So, if I took one of these out of the picture, let's see what we have. We have this right here, so let's add it there. We have this right here, so let's add it there, and then we have a tick mark here. Do you see how when you pull it out of the crazy overlapping picture, it kind of helps? There's our clarity. Oh my goodness, it's angle, angle, side, because the tick mark is not between the arcs. Vertical angle theorem would not help us here because that is not one of the angles of the triangle. Like here and here, those are angles, but those aren't one of the three angles of a triangle. Angle, angle, side would be the answer to that one. This one's overlapping, but it's actually way easier than the one before. When in doubt, if you're ever in doubt of what triangles you're supposed to be using, pick the overlapping one. Pick the one that uses the whole picture. You know what I mean? Like if you were using this triangle and this triangle, well, you wouldn't be using all that space in between. So those are not the triangles we're asking about. We're asking about this triangle. Is it congruent to this triangle? So when you're wondering which triangle to use the whole picture. Don't leave a big chunk of the picture out. Okay? Because yeah, there's a lot of triangles. When you overlap triangles, you create many triangles. The other one. So once again, we have a shared side. We've never really had a shared side like this before, but hopefully it was really obvious. There's our shared side, and here's our angle, side, and then it's this angle right here, actually. I wonder if it'll let me pull that out. See right there? Too bad you can't do these things on your worksheet. That would be so cool. One day you'll be able to. So when I pulled everything else away, I was left with our angle, side, and that big angle over there. Go ahead. Only two more examples left if you're still in the lesson. Alrighty. We have vertical angle theorem. Ooh, we have parallel lines. Pick a transversal, any transversal. Alternate interior angle. So, angle, side, angle. But you might be thinking, what if I had picked the other transversal? Sometimes there are multiple right answers, and I would mark both of them right on a quiz. So these would be the two acceptable right answers. It has to have two A's in it. Angle, side, angle, or angle, angle, side would both be equally right. There's not even one that's better than the other. Okay. Last example. I think there's already been some like this on the homework, but we've got our reflexive property of equality, the shared side that we're used to seeing. Here's what is very, 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 very important. Here's what's very important. We have to choose the correct alternate interior angle. So these are my parallel lines, and I'm using this transversal, because those other transversals won't help us. I have students mark the wrong alternate interior angle. Make sure when you draw that arc, you touch the parallel line and the transversal. You touch purple to purple. So, am I going to put the angle here? No. You see how that's not where you put the angle? So that's really important. There we go. Touch purple and purple. See how I'm touching both? I'm touching both. See that letter Z? It's like making the letter Z or N or whatever you want to call it. You have to put them in the right spot. The angles do not go in the other spot. Okay. So that's where my angle markings go. And now it looks like I'm in trouble. I've got angle side, side. I've got two sides in one angle, and the angle is not between the sides. So this one, believe it or not, this one is not possible. Now, had the other two sides been parallel, then it would have been, let's see, side angle side. It would have. But the wrong two sides were parallel, so this is not enough information. I can't prove these triangles guilty. Okay?